In this section, we'll talk about how to model this flanged part into 3D. So we have here a situation where we have a flange at the base. The flange is made up of the circle, a bolt hole circle, which is of a diameter of 50, and then we have the 4 holes, which have a diameter of 10 each, and the whole flange has a diameter of 70, which you can see here. Then we have a cylindrical element which has a diameter of 30, and this element makes the flange to be 50 in total. And inside that cylindrical body we have a threaded hole, which is a blind hole. So that means that this hole is not a through hole, but it stops right here, and it has a thread because we have this M20 here, and this is the root of the thread, and this is the crest, and this is the exit point, and then the rest here is like the hole without any thread. And also we have here the drill mark, which is 120 degrees here, and this is the part that we need to model into 3D. So I'll start by creating a new drawing and have this as a reference. So new drawing. F7 to disable the grid. Units to change the units to millimeters. And then we have to create the flange first. So the flange has a couple of circles that need to be created. So the 70 diameter circle is the whole flange diameter. So C enter, 0, 0, D enter, and 70, and double click the mouse wheel to get the whole diameter. Then we have the bolt hole circle, which starts from the origin point and is of a diameter of 50. And we need one line to help us establish where the intersection between the bolt hole circle and the axis line is, and it's here. And the dimension of the bolt hole is the diameter of 10, and this, we don't need this anymore right now. We can array this with the polar, and we can select the center here and hit I on the keyboard to select four items. Tap enter. Now this is a single element, so we need to explode it. So we explode this and we get four individual elements. Okay, so we don't need this circle anymore for the modeling purposes. That is not necessary, and now we need 2 more circles. One is of a diameter of 16 and the other is dimensioned here to be 30. So we need those 2 as well. 0, 0, and the diameter to be 16. Repeat by tapping enter, the add symbol enter, D for diameter 30. and we have the two diameters here. And now we have to take a final look here to see. So we have the flange, the outside diameter. We have the holes aligned, the bolt holes, all four of them. We can extrude the flange, and also this cylinder here, the outer one, we can also extrude that. So we can go here, switch to an isometric view like that, and use the extrude command to extrude these four bolt holes and deselect this one, and we tap enter and give the diameter, the height of 10, and the other two need to be 50. So extrude those two, this one and this one, to be 50, and that is because we have the outer one to be like from the bottom towards the top, we have 50. So we don't actually need the 16 right now, just need the 30 diameter one. And we can now create our two layers. So new layer, we'll call this inside for the inside geometry. And the other one is the outside for the outside geometry. And we'll change the color so we can see them better. For the outside, I'll use this orange. And for the inside, I'll use red. Okay. And now I'll just make sure these two are on the outside layer, and these four need to be on the inside layer. Can switch to conceptual to visualize this. So we have this situation, but the inside geometry here is more complex, so we will create it separately. So we have here a situation where we have a thread. So this is drawn conventionally with the tip, with the crest here, drawn with a thick line, and the root drawn with a thin line. But when we draw them, when we model them, we have to make it so that they appear like they have individual teeth there. So we need to model those. So we have this cylinder part here, which is 30 millimeters. Then we have a chamfer part here, and on a length of 20 millimeters, we have also the thread teeth. And how high are these? Well, because this is 16 and this is 20, that means that the height of the tooth is 2. So there are multiple ways to model these. The easiest one is to actually create the teeth on one side and then the whole geometry, and then revolve it on the so that we have the negative part, and then we can subtract it from the positive and we'll get the inside hole. So this is what we'll do. So to draw this geometry, we can use like the line, and draw like a, let me activate my ortho by pressing F8, and I want to give this a length of 30. Okay, and I gave that a length of 30 because this is also 30. Okay, and what I want to do next is, because this is 30, at the very top here it has like this chamfered edge, and we need to figure out, we need to model the inside geometry, so not the outside. So this needs to be like that for 2 millimeters. So we'll go here and actually draw this as like a 28 millimeter or actually we can draw it like that, like 30 millimeters, and then we'll go like that for 10, for example, and then we'll use chamfer angle 245 and select these two to get that chamfered edge there, but we don't need this line here, just needed that edge. So we have the edge like that. Then since this is of a distance of 20, so from the root edges of the thread we have 20 millimeters, then half of this is 10. So we can do an offset of this at 10 millimeters. So offset by 10. And this is actually like the, so I have to be careful here because this is 10, but it's 10 from the root, but not from the crest. But I draw the crest, so instead of drawing it, I have to offset it by 8. So delete this, offset by 8, this one, and also I want this to be extended that way by 2. Okay. Now I'll join these with a line, and down here as well. So I drew this part here all the way here and like that. So I need to also draw half of this V shape here, triangle, and to do that I know just that this angle here is 120, so half of it is 60. So the opposite one, because it's a square, it's a right triangle, then this is 30. So I have to create a line that is at a 30-degree angle from this line. How long should this be? Until it intersects with the axis line. So in this case, let me switch to my top view here so can understand this better. So in this situation, I'll draw a line from here and I'll say at 15 less than sign and 210 and enter. And then extend this a bit and trim, and I don't need that line anymore. So now I got the overall shape here. I can join it because I want it to be one shape. So it's one shape in the way it's modeled, now drawn, and now I have to revolve it so I can get a 3D version of this. So to be able to do that, I'll use the revolve command, and I'll select this profile here, and the axis line is from here to here, and I'll tap enter to get a 360-degree angle. And if I go to my isometric view, you can see we have it. And now we have to place it here so that we can get the differencing between the two. So in order to do so, we have to rotate it and then place it here, and then subtract from the large part the smaller one, and then model the thread teeth, or we can model the thread teeth before and then place them there. So let's model the teeth first. So Control Z a few times, and we're left here, and now we have to create the teeth for the thread. So since this is of a length of 20, we want to offset the length. So this line here, now I need this to be exploded again. So explode this. And offset by 20 this line here, like that. And now I have to copy this. Actually, I'll draw it. So line, and from here I'll draw towards the bottom. I'll draw a 2 millimeter line. Okay, and then towards the right I'll draw a 2 millimeter line, and then from here downwards another 2 millimeter line. Then I'll just join these like that to get a profile, and I don't need this line anymore. It was just, sorry, not that one, this one. It was just for construction purposes. Nor this one, nor this one, they overlapped anyway. And now I can copy these two oblique lines here a few times until I get my intersection with the exit line here, and I'll delete this one. So this is the part where the thread ends. So I'll have to trim that axis line here and delete it overall from there. So I have the teeth properly set. And this line, I only need that part of it. Okay, and now I can join it. So join the lines to be as one. And I can also move this and rotate it before I revolve it. So let's try to go to the isometric view, and remember the 3D rotate command to have this upward, like let's see, this is it, and we'll rotate it 90 degrees. Not like that, we want it vice versa. So 3D rotate this one minus 90 degrees. Okay, and then we want to move this geometry from here to the center point here. So the center point there, and we have it there. Now we'll go into 2D, to the 2D view, wireframe view, and we'll give the rotate command. Select this profile, select this axis line here, and so we needed to, revolve it. Revolve from here to here. And we tap enter, so we have it a 360. Then we get this inside shape, and we place it on the inside layer. We have it there. And we are ready to perform the subtraction for our final part model. So we'll go to the 2D wireframe mode again, type in subtract, and select the outside geometry, and then select the inside geometry, not that one, and tap enter to perform the subtraction. Now we'll go to our conceptual view to see our threaded part with the blind hole inside. Let's do a section plane, and we'll go from the quadrant of this flange here. So let's do section plane and then quadrant from here to, let's try that again. Section plane from here to there, and you can see, now we can see inside. And we can see we have our thread here with the chamfered edge, with the teeth, with the exit, and with the blind hole that ends with the drill mark here, and our flange at the base. And this is how we model the thread. It's one version, one method on how to model these.